So, hi everyone, thank you for coming along. Sorry, some of it was a bit short notice for people, but we're very lucky today to have Alun and Gerard along from UPF. UPF are one of the partners on the IMPART project. For those of you who don't know what IMPART is, it's the EU R&D project that we're doing, which involves processing of data from onset through our pipeline in a more efficient manner, especially the big data we have to handle these days. All the partners are working on various tools to improve that workflow, make it more efficient. UPF today, you're going to talk about some of those technologies, and
Absolutely.
Ideally, in the long run, we're going to be integrating that into our tool set. So, over to Alun.
Great.
Thank you.
Thanks very much, Jeff. So, hi everyone. I'm Alun Evans. Just very briefly, why I'm here and who I am. So I work at Universitat Pompeu Fabra, which is one of the bigger universities in Spain, in Barcelona. And I have been working there for a while now. I did my PhD in London about 10 years ago, UCL. I'm from South Wales originally. And that PhD was in 3D medical imaging, really, I suppose. Then I moved to Barcelona after that to do some work in character animation. Then I made a video game to do with, an MMO video game to do with the Barcelona World Race, which is a big sailing race. And that was quite an interesting experience because in that game, the goal was basically to create an MMO which enabled a virtual sailor to sail your virtual boat around the world in real time, competing against the real boats with the real weather and all that kind of stuff. And that was very fun. Hello.
What's an MMO?
An MMO is a massive multiplayer online game. Sorry to use the terminology. So, and the reason that game was quite a big success, and one surprising success was it at the time, was 4 years ago, was that it was one of the few games that used 3D graphics in the web browser. So the majority of games you'll play these days, they might use 2D graphics, 3D graphics, but you'll download the game and you run it on your computer or your iPad, your PlayStation or whatever it is. But this is one of the very early games which used 3D graphics in your browser. So when you logged in to sail your virtual boat around the world, you also had a 3D representation of your boat, and the sun was setting, you could see the sun setting and so on and so forth. And that was very interesting, and that got me thinking a little bit about what more things can you do with 3D graphics on the web. And then around about that time I went to work in the startup world for a while, for a couple of years, doing 3D graphics actually to do with virtual fitting of garments and showing you your clothes online in virtual shopping before you bought them. So that kind of worked, except for the fact that we found that people don't like seeing a real virtual representation of themselves before they buy clothes, because not all of us are supermodels, and perhaps it's not a great idea to show exactly a 3D model of how your body looks like when you're wearing this t-shirt or whatever. And so that startup went the way of many startups. So now I'm back in the university, and specifically working on this European project, which it's quite a large European project. It's got 6 partners, it's got Double Negative and Filmlight, the colour correction hardware company here in Soho, as the main industrial partners. Then it's got 4 other universities all around Europe, and the idea is we're sort of trying to collaborate to sort of bring academic research and R&D in the production world a little bit closer maybe, and both learn from each other in that sense. And I guess another reason I'm here is as a bit of an evangelist. Like, I think that 3D graphics on the web is going to really take over. I'm happy for you to disagree with me, but let me try and convince you over the next half an hour or whatever, and we'll see how it goes. And most importantly, I think you'll see that it's a technology that's in its infancy, and hopefully I'll convince the people on the other side of the line there as well. So it's a technology still in its infancy, and I think you guys work on the very cutting edge of the highest level of visual production. And so I think perhaps your first reaction is going to be, well, it's not good enough. And it's not good enough. But I think nothing was ever good enough when it started, and I hopefully will be able to find a way where the benefits of using web-based technology start to outweigh the negatives. So you know, the classic thing they say when you start a presentation is always start a presentation with a question, right? And I thought, I'm going to start this presentation and say, who uses like Google Drive or Dropbox? And I thought, what a stupid blinking question, right? Because everyone uses Google Drive. Everyone's been using web-based or cloud-based email for the last, 10 years when Gmail and Hotmail came out, right? And now, with Google Drive and iCloud and SkyDrive and Dropbox, now the concept of saving your documents or your assets or your movies or your photos in one location and then having to transfer them with a hard drive or USB or even do backups of them, with your personal data in particular, it's almost alien to us now. Like, we're so used to the concept of everything. Like with my phone, I take a photo and like 5 minutes later it says your photo's been uploaded to the cloud. I can share it without even asking me to do it. It's up there, And so we're becoming used to this idea of everything being able to be done by the cloud, via the browser. And the one exception to that at the moment is 3D data, whether it's a mesh or a texture or a material or any sort of asset that you might use in 3D graphics. We're still not used to seeing that browser-based technology being used in that field. And the reason is that for many of us who have any sort of experience with 3D graphics on the web, you might say, well, browser-based 3D looks a little bit like this, right? And well, that's crap, isn't it? Because that's just basic flat shading from a virtual tour of a city I think was done maybe 10 or 15 years ago. And it's not very good. And I think we're getting to the stage now where 3D graphics in your browser looks a bit more like this. It's obviously got aliasing issues, it's obviously got resolution issues, but it's much, much better. It's got real-time reflections, and it runs in your browser, and it's approaching the level of graphics that you'll see in a modern computer game, either in your hardware, either in your console, or in your PC, or whatever it is. And I think the fact that we're reaching this quality in real time in your browser is a really big thing today, and I want to talk a little bit about that and where I think it will go. So, where does 3D graphics on the web, inside your browser, inside Google Chrome or Safari or Firefox or Internet Explorer, where does it all come from and where is it going? So it started off with this technology called VRML, which stands for Virtual Reality Modeling Language. And this was maybe about 20 years ago, and this was running in, well, Internet Explorer 6 or 5 or something. And obviously it was it stayed in kind of like research level, I think. It was designed to do virtual visits to museums and tourist attractions and all that kind of stuff. And it was well behind the times in terms of visual rendering. But it was a way, the first way in fact, that you could connect to a URL on your browser and see some sort of 3D graphics running. And then we moved on to another technology called X3D. And I've kind of chosen a very nasty image here for X3D. And I feel a bit unfair because X3D is actually now a very mature technology which allows you to make some pretty impressive graphics. But I've chosen it because I don't particularly like it, so I'm putting a crap image. And what's interesting about X3D and VRML is that they both actually deal with more with internet-based 3D rather than web-based 3D. What's the difference? Well, web-based 3D is graphics that run in your browser, whereas internet 3D is something that runs in an application that isn't necessarily your browser. So, for example, the very successful video game World of Warcraft is obviously a big online game, and it's internet-based 3D in the sense that you have to download the application full of 20 gigabytes worth of 3D assets first, and that's running on your local machine, and then it's connecting with the internet. And I think the big change recently has been a move away from that necessity to download and install software onto your computer and actually move into a world whereby you just have your usual browser, which you used to use Gmail or browse the web or whatever, and you type a URL and you start having that 3D experience right there in your browser. No, back. So, we all know about Flash, and Flash was one of the early ways of having more interactive graphics, if you like, working in the browser. So those of you who used the web back in the early 90s would have sat through indeterminately long loading pages as people made their posh Flash websites when the designers took over from the engineers and said, we're not having this rubbish HTML rubbish, we're having Flash graphics, right? Flashy graphics. And there's a little bit of you can do now 3D graphics with Flash as well. But one of the downsides of Flash, and the same downside with X3D and the same downside with Vermal as well, is that they all require you to install a plugin in your browser to work, right? If you don't have the Flash plugin, you can't execute Flash graphics, either in 2D or 3D. And in the standards-based world of the internet, that's a kind of anathema, and the internet powers that be, who don't work for Adobe at least, are trying to move towards a scenario whereby with one software which is standards compliant, you can execute everything over the web, which is the goal really. Another plugin-based thing is Java. Some of you might recognize this game as Minecraft. Minecraft is an extremely successful game, made loads and loads of money for Mojang, the creators. And this is built in Java, right? It's a technology which you use to create. It's also a plugin that you might have run when you want to do something in your web. And that's fine. But in 2010, 2011, this thing was launched. And this thing really is I think the birth of modern 3D graphics in the browser. It's called WebGL. It's basically a web version of the popular real-time graphics API, which is OpenGL. So OpenGL and Direct3D, the two competing ones. So pretty much any 3D application that you will use on your computer these days runs OpenGL or Direct3D, right? And unless it's a custom hardware that you might find in your PlayStation, your Xbox, but even those are using modified versions of the same libraries. And WebGL is a standards-based, semi-open source, certainly not proprietary, method of writing code for 3D applications that will run in your browser. And they let you do things like this, and this is an application that I wrote a couple of years ago for this virtual fitting, for example. And so here we are in Chrome, right? And here's a 3D what you call it, a jumper or a jersey. And the advantage of this is that you have a standard web page around it, right, which is on top of the 3D, if you like. In that sense, there's an integration, a seamless integration between the HTML and the 3D in the background. So you've got the 2D standard web page and a 3D more interesting web page in the background. So here, for example, I can load an image on this and zoom in and move the image around, and then I can add some text. I don't know, I'll say, hi, Justin, and then update, and then it appears. And this is the idea of being able to customize, have a web page that you can customize a product, customize work, customize the experience, I guess, using a more interactive way of doing things. And so that's all well and good, but what we started to do in the last few years at UPF is to see where we could take that, and especially with regards to the 3D production world. Now, anyone who's worked with 3D graphics on the web at the moment is aware of this library called 3JS, and that's a very, very important step, because usually 3D graphics requires the programmer to know a little bit about 3D graphics, right? You need to know about meshes, and you need to know about matrices and transformations, and you need to know about moving things around and quite a bit of maths and so on and so forth. And this library here is one of the first efforts to really take that to a higher level. So your average web programmer with not much knowledge of 3D can just go, okay, well, okay, I want to make, you know, for example, this image, this one on the left here is the promo page for. Is this going to link? Yes, it is. This one on the left is the promo page for the Gravity film, right? And this is all built in 3JS, which is a. Is this going to load? I'm not sure where the actual app. Is this the one? No, back. No, that's the app. Do you know where it is, Gerard? I've forgotten.
Can you say the Spacewalk?
Spacewalk. Oh yeah, that one. Yeah. So, and this was the official web page of Gravity, and they decided when they were making Gravity they wanted to make a 3D graphics interactive application loading on the web, so it would allow users to sort of have that Gravity experience on the web. And this was built, most importantly, with a very high level library that non-3D programmers could do it. Let's see if we can just quickly skip the intro. And so here we are. This is all real-time 3D, and it allows you to zoom in on the space shuttle. Can we click on that, please? Well, I'm not sure about the. Oh, here we are. Click on that. There we go. Might zoom into it. So again, it's not like production quality graphics, but it's pretty high quality. And again, the most important thing is it's just running straight in my Chrome browser, so I don't have to worry too much about installing anything, you know. Okay, so the most important thing about that library is that it doesn't require you to know much about 3D graphics. You can do it at a very a web-based level. So your average web programmer could create that web page, obviously if they had access to the assets. So, to summarize, 3D graphics on the web is difficult because it requires you to have some programming knowledge. Your average artist can't come along, make a model in Maya, and then deploy it onto the web. You need to have some knowledge of 3D graphics. The quality is still an issue. Like I showed you, that screenshot I showed of the car earlier on is kind of representative of some of the best quality you'll get, but you'll see it's nowhere near cinema quality. It's approaching video game quality, I think, but it's nowhere near cinema quality. And there's a thing where WebGL, the web version, is not quite as powerful as the OpenGL real-time graphics, which is nowhere near as powerful as the non-real-time graphics rendering. And Justin was telling me earlier on about how in the Fast and the Furious there was those scenes with a plane crashing, which was 100% digital. Do you know what I mean? And you know, we're reaching that photorealistic quality now, which takes an age to render, but the quality is spectacular. And of course, web-based graphics is well away from there. It's very difficult because if you've got a 200 megabyte file for a mesh that you've made in Maya or something, then transferring that file across the network is going to take time, right? It's 200 megabytes. And 200 megabytes doesn't transfer like that, even with this incredibly fat pipe that we have here in Double Negative, which incidentally I was extremely pleased to find out because it means I can show you some very high resolution demos. Even with that fat pipe, there are issues of transfer of assets and loading times and all that kind of thing, and that's kind of a research issue that's making things difficult. Your average web browser is not as powerful as your average application that you might write, custom application that you might write in C++ or whatever. The web browser uses a language called JavaScript, which is not quite as powerful as the standard languages you might use to write technology. It's a bit of a jack of all trades. It's good at doing everything, but it's not a specialist in anything. And so that is a little bit slower. It requires a little bit of effort and care when you're creating your application. And one issue I think is particularly relevant for you guys here in Double Negative, because you're working with these, you know, posh guys in Hollywood who always want to have security and they're worried about the leaks of their assets and all that kind of stuff and the images. Well, if you're transferring things over the web, then security is a real issue, you know, and you don't want the risk of anyone hacking into your website and downloading some top-of-the-range asset or render that Hollywood wants to reserve for a promo or whatever. So. Security is a real issue that I think is particularly relevant for Double Negative. And the final issue that doesn't exist anymore was this issue of Apple, right? And Apple, being Apple, decided that they didn't want to implement WebGL and all these real-time technologies in their mobile Safari on their iPads and the iPhones. They said, no. That might take sales away from the App Store, so we're not going to do it. And so for the first 2 or 3 years of the existence of WebGL, Apple said, no, fingers in the ears, not doing it, until just last month or whatever it is, Tim Cook stood up on stage and renounced iOS 8. And I have, from the horse's mouth, I have a friend of mine right now who's visiting a friend of his, who's a developer at Apple, who's got a build version of iOS 8. And we've been testing out our tools on an iPad on iOS 8, and very pleased to say they work flawlessly. So. Eventually Apple has caught up with the rest of the world, and I think the fact that Apple and also Microsoft, and they've all come on board with this WebGL standard, I think it means that the door's now open for this web-based 3D to really push forward. And it's good. And why is it good? Well, the first reason it's good is that for all the reasons that Google Docs is good, for all the reasons that Dropbox is good. You know, I was writing a document just the other day with some friends. I'm here in London at the moment, they're back in Barcelona, and we can still collaborate on that document. We can edit it in real time because I can log into Google Docs and I can start playing with it and typing things, and they can start playing with typing things. We can comment, we can chat. And this ability to collaborate and share, and most importantly, work remotely, is a very, very important point. I'm going to talk a little bit more about remote working in the 3D production industry in a bit. And I know it's less of an issue here because you guys were in 3 different buildings. Now you're all in one building, right? So you're all on the same intranet. But I think there are lots of smaller companies in particular that are more distributed. You might have a producer working here with a modeling company working here and an animating company working here, and you're all working on the same project. And thanks to the internet, you can work together, but the workflow isn't quite as tightly integrated as you want it to be. And so the web allows you that remote working that you might not have. You don't have to install anything. You don't have to install Maya, you don't have to install your renderer, you don't have to install World of Warcraft or whatever it is. You just install Chrome and you go, right? And that's a really big thing, because if you send a demo to a client, you say, I'll open it in Chrome or open it in whatever you want. You don't have to make sure they've got the right libraries, the right software, and there's no conflicts and the system's not crashing and so on and so forth. And so it leads to the concept of anywhere and any machine. And I put in probably, because there's always somebody who's got a rubbish laptop who tries to open it and it doesn't work, and they say, your demo doesn't work, well, it's not my fault. So there's a little bit of a last block there, but I think as the general power of machines improves, that's becoming less and less of an issue.